Okay, so this is lesson 14, but before we get started with that, I kind of wanted to remind you of how we want to see your work. So if you notice, when I show you my work, I kind of spread it all out. There's a lot of white space around. This one's probably a bad example. When I taught 6th grade math, I saw an awful lot of this. You'd make these little tiny boxes, and then your answers would be kind of messy, and they wouldn't be lined up. And I wouldn't necessarily be able to read them, and your answer might not be boxed if you had a lot of work. And so I'd be squinting my old eyes at this, trying to figure out what you're trying to say there, and what does that mean, and I don't know. So spread your work out. Do not make these little boxes ahead of time, because what if example 4 took 18 lines? You never know. So I want to see your work. I do not want you to just put your answer, okay? So I want to see what you're thinking. Show your thinking. One thing I wanted to show you is if you are insistent on little boxes, this is a pretty good way to have boxes. Look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Usually you have 15 problems, so you might have to do 2 of these. You could probably fold it a little smaller, but that way, if that's all number 1, that's all number 2, man, it would be so much easier to grade and for us to understand what you're thinking. So just wanted to tell you that. Okay, now we're on to lesson 14. So this one's missing numbers and subtraction. I know you've learned about fact families forever, so we're going back to fact families. And we're going to say 3 plus 4 equals 7, and 7 minus 4 equals 3. I could make other problems. I could say 4 plus 3 equals 7, and 7 minus 3 equals 4, right? So we're going to learn how to take this problem, this addition problem, and read up to make it a subtraction problem. So 3 plus 4 is 7, but if I say 7 minus 4 is 3, I'm just doing it the opposite way. I'm reading up, and I get 7 minus 4 equals 3. So I flip it upside down. I have an inverse operation. This is addition, and the inverse of addition, or the opposite of addition, is subtraction. My problem lined up this way, and the inverse, or the opposite of it lined up this way, is this way. So that's pretty cool the way that works. I can use my fact families to make 4 equations, like I said. So sometimes you'll see it drawn like this, because 7 minus 3 equals 4, or 7 minus 4 equals 3, or 3 plus 4 equals 7, or 4 plus 3 equals 7. So sometimes you see flashcards like that. I don't know whether they still do that or not. Okay, example 1, they say, reverse the order of these numbers to make an addition equation. So they gave us a subtraction problem, but they gave it to us horizontally rather than vertically. I think it's easier to think up and down rather than across, so I'm going to write it this way. Now I'm going to read up. So instead of 68 minus 45 is 23, I'm going to say 23 plus 45 is 68. Remember, I'm doing the opposite. 23 plus 45 is 68. So that's my opposite operation, or my inverse operation. So you reverse the order you use the numbers, right? I got a little carried away on example 3, sorry. So example 2 is the same idea. So if they want me to make an addition problem, I'm going to read up. 54 plus 23 is 77. 54 plus 23 is 77. The same idea, okay? Example 3, we're going fast, but I think you've got this stuff. Has a missing addend. Remember, an addend is 2 numbers that you add together to get a sum. So this one actually is a missing, this is a minuend. Remember, one of the subtraction terms. So something minus 15 is 24. So before you do anything else, let's think about that just a minute. That F has to be bigger than 24, doesn't it? Because I'm taking 15 away and then I'm getting 24. So I know that f is much bigger than 20, not much bigger, it's 15 bigger than 24. So if I read up and turn my problem around, I say 24 plus 15 equals f. And I can do that right here, add them together, and I get f equals 39. So now we have a rule. The first number in a subtraction problem can be found by adding the other two numbers. Okay, so let's think just a minute. Let's say, I don't know, 2 plus something. So something plus 2 is 5. Well, they said this first number can be found. Oh, that's a subtraction problem. I'm gonna have to do, never mind. Okay, minus 3 equals 2. Okay, so how am I gonna find that? The top number, the first number, can be found by adding these, right? Always go back to a problem that you know. And my favorite one is either 2 plus 3 equals 5 or 2 times 3 equals 6. Man, that saved my bacon a lot of times to be able to figure out how something worked that I already know the answer to. Okay, so we have a rule. First number minus the second number equals a total. Or I can say the total plus the second number equals the final number, the first number. Okay, example 4, we're missing the second number, and that's the subtrahend. So 45 minus something is 21. So is that S, we're thinking about it, is that going to be more or less than 45? Well, it's 45 taking away something less than 45 to get 21. So they tell me now that I can swap places. So instead of 21 being the answer, it can be this one you're subtracting. Okay, so 45 minus 21 equals an S. And my S's look like 5, so that's an S. And I know that S equals 24. Again, go back to what I know. If this is my missing number, 5 minus something equals 2, how do I find the 3? Oh, 5 minus 2 is 3. So even on those problems, I can just swap places. Okay, so you have a new rule now. The second or third number in a subtraction problem can be found by subtracting. Swap the places if necessary. Cool? Okay. Example 5. 5 years from now, Kendall's grandfather will be 60 years old. Which equation can be used to find the grandfather's age in years now? So I know that he's however old he is. But in 5 years, he's going to be 60. So is he older or younger than 60 now? If I write myself a little equation down, let's not even look at the answers in the book just for a minute. Let's figure out our own way to do this. So now, plus 5 years, he'll be 60. Oh, so now I have a problem where I can do what? Can I read up? Sure. So now plus something. Sorry, now plus 5 equals 60. So now I can read up. 60 minus 5 is now, so 55. So I know that that first equation, instead of now I have an A, is the correct one. You have to play with that a little bit. It can get a little bit confusing when you have word problems. I want you to always ask yourself, is that number likely to be bigger or smaller than one of the other main numbers? And then figure out why. So that's how you can kind of check your work. Okay, so that is lesson 14. Remember, go back to a problem that you already know the answer to. Figure out how you got that answer, and you can use the same procedure. Okay, good luck.